Alright, this is Unit 1, Day 6. We're going to keep going with the systems of equations, 3 equations, 3 variables. Except now we're going to do elimination, which some of you probably did a little bit of in Day 5. You get to choose, and honestly, 9 times out of 10, I'd probably choose elimination when I'm doing these guys. But the big thing here is, like, when there's 3 equations with 3 unknowns, you're going to have to combine 2 of the equations and then pick a different pair and combine them. And our goal is to produce 2 equations with 2 unknowns from that. Okay, so when I'm looking at this, I'm trying to see, it sure looks like the y's would easily wipe out. If I combine these 2, the y's would wipe out. And then if I combine these 2, the y's would wipe out again. You could do x's, but you'd have to do some multiplying before it worked. Same thing here, it'd be several multiplications. But right now, I could just combine the first and second equation. And I'll just do that right now. So for 1, when I combine these 2, when I'm adding them, it would be 8x. The y's would cancel out. I have 7z's, so plus 7z. That would equal 18. Now, again, that's 1. Maybe I'll do this. I'll do 1 and 2. I'll just put 1 circle, 2 circle. And then when I do 1 with 3, I'll just write this. I'm going to combine 1 and 3 together right now. So 2x plus 2x is 4x. 3y minus 3y is 0, and then 3z plus 2z would be a 5z, and then 6 plus 6 is 12. So I had to do 2 pairs of these such that the same variable canceled twice. So the y's canceled, and the y's canceled again. It has to be the same variable wipeout both times. So now I've got 2 equations, 2 unknowns. This is just like we did before, and take whatever approach you want. Like, I think the x's would be pretty easy to get rid of here. So if I multiplied that by -2, I would have a negative 8x minus 10z equals negative 24. Okay, and kind of ignoring these for a second, just look, the x's wipe out now. So I'm going to ignore that middle line. So I have no x's, I have negative 3z's, and then I have negative 6. Negative 6 on the other side. So divide by -3, I got z equals 2. So that was pretty fast. Make sure this is more of a z and that looks more of a 2. That happened a lot faster than with elimination. With substitution. This is a good one for elimination. Some of them substitution is required. Like, you have to do it. Some of these eliminations faster. So now that I have 1 variable, I'm going to find the equation that has 2 variables. It's these guys right here, because there's none up there that have 2 variables. So pick one of these guys and plug it back in. I'll just pick the first one, make it easy. So 8x plus 7 times 2 equals 18. So 8x plus 14 equals 18. Subtract 14 over. I've got 4, and then divide by 8. So x equals half. Okay, now that I have x and z, I have 2 of the variables. Look for an equation that has 3 variables, and that's any of these 3. So any of them will do the trick here. So 2 times a half plus 3 times y plus 3 times 2, because z is 2, equals 6. So I'm just using that first equation here. So this would be 1 plus 3y plus 6 equals 6. So this is going to be a 7. 1 plus 6, I'm going to subtract 7 from both sides, and I would just be left with 3y equals negative 1, and divide by 3, and you get negative 1/3. Now most of your math Excels are going to have whole numbers. Here's an example that has some fractions in it. I guess go on to the next one. Again, at any point, try to pause. It might make things easier for you if you pause and try it yourself. If you get stuck, look back at the video, see how you're doing on these. But it looks to me you could either do y's or z's, kind of attack one of those 2. Maybe we'll do the z's on this one. I don't know. I just have a feeling to feel like doing z's on it. So I'm going to try to get rid of the z's. So I'm going to combine these 2 first. I'm going to have to double the first one. So the first equation, I'm going to double it. So 2x plus 2y plus 2z equals 6. Combine that with 2x minus y plus 2z equals 6, and add straight down. I'm sorry, I need to do a negative on this, so these all going to be negative. I totally missed that step. So I'm going to multiply by negative 2. So I took the first one times negative 2 to get all these. So the x's will disappear. That's kind of nice. And then the y's will be negative 3y. The z's disappear, and it's kind of a twofer here. We got rid of two variables on accident. You know, we were trying to get rid of the z's, got rid of the x's with it. And that's awesome when that happens. So I got negative 3 equals 0. Just because you have a 0, that's not a bad thing. I think some people get nervous because, like, oh, 0, that must mean no solution or infinite solutions. It's if the variables disappear. So I still have a variable. I'm still going to divide. So y must be 0. And here you might get kind of stuck because you say, well, I got one variable. I don't have any equations with two variables. Well, go back up here. Let's do this next combination. I'm going to put these two together, but I'm going to double this one. I'm going to double the third equation. So top equation, or the second equation, and now double this. So 6x plus 4y minus 2z equals 26. Let's add straight down here. So I've got 8x. I've got plus 3y. My z's are gone, equals 32. So now I have an equation with two unknowns. Let's plug this guy in. So that would be 8x plus 0, because 3 times 0 is 0, equals 32. So divide by 8. X must be 4. Okay. Now that you have two variables, pick any of these guys up here, whichever one looks nicest to you. So I'm just going to pick that first equation before I multiplied it. So just x is 4, y is 0. I'm trying to solve for z, and I'm getting 3. So that's 0, subtract 4. Z was negative 1. Okay, I'll do one more of these. Just say that, just like with substitution, there will be times where the x, y, and z's all cancel out. Same rules apply. If they all cancel out, then it's either infinite solutions if it's a true statement, 0 equals 0, and it's no solution if it's not true, like 2 equals 0. Okay. So let's try these guys. It looks like the z's again. I'm going to look at the z's, try to get rid of those. If I just do these two first, that's going to take care of things pretty, because the z's will already cancel out the way they're written. So that'll give me a 16x plus 10y equals a 28. Okay. Now I'm going to do these two together. I'm going to have to double the top. So I'm going to take the top times 2. So it'll be 4x plus 2y minus 2z equals 10, and then x plus 4y plus 2z equals 16. So there cancel out, so 5x plus 6y equals 26. And I need to put these guys together. And it looks like probably the y's. I go after the y's. And the least common multiple of 6 and 10 is actually 30. So I need one of them to be negative, so maybe I'll do negative 5 and positive 3. So this will be a negative 30 and a positive 30, and then the y's will cancel out. So this is going to be negative 25x plus 30y equals it'll be 130. But it will be negative. And then I've got 48x plus 30y. Ooh, I missed this negative 2 right here. So negative, negative, negative. And then equals, what would it be? Let's see, 60 plus 24, 84. Okay, now I'm going to add straight down here. So this would be a 23. This would be x, and that would be a negative 46. So I divide by 23. X is negative 2. So, like we said yesterday, once you got your first one, you're about halfway done. Okay, and once you got your first variable, pick an equation with two variables. One of these guys, one of these two guys. So I'll just do 5 times negative 2 plus 6y equals 26. So negative 10 plus 6y equals 26. I'm going to add 10 to both sides. 6y would equal 36. So y is 6. And then now pick an equation with two variables, or I'm sorry, with 3, because we know 2. Pick one with 3. I'll just pick the first one. So 2 times negative 2 plus 6 minus z equals 5. Negative 4 plus 6 minus z, this would be a positive 2, so we'll subtract 2 from both sides. So negative z would equal 3, that means z is negative 3. Okay? So I'm going to stop. I think this one, we don't need another example. I think you kind of see how it's working. Just keep in mind, if the variable is wiped completely out, then that means there's an infinite solution, no solution situation. If it is true, it's infinite. If it's a not true statement, then there's no solution.